So we said that the electron is outside the nucleus. So we know the protons and the neutrons are in the center, they're in the nucleus of the atom. But the electrons orbit the nucleus. But they're not just orbiting the nucleus randomly in chaotic fashion and we don't know where it's at. They're actually in certain energetically allowed energy levels. So instead of thinking about my staircase, if I think about the nucleus being the middle, they're gonna be in levels outside. You can almost think about it as kind of like a ladder. And so they're going to be in little areas, energy levels, that are allowed. Now remember that these levels are quantized. Okay, so let's talk about what is quantized. So quantized is because energy is always emitted in whole number multiples or levels. So remember we talked about our quantums. Okay, so these energy levels are quantized. You're either on this one or you're on the next one or you're on the next one. And each one of those little steps is a quantum. Okay, so each one of those energy levels has a certain amount of energy that is associated with it. And then when I go up in energy, this is a new energy, and etc. And each of those energy levels are quantums. That's why it's quantized. All right, there are several energy levels out from the nucleus. So if I'm here, I'm going to have a lot of different energy levels going outward from the nucleus. Each level has more and more space. Okay, so if I'm here, I'm really close. I don't have as much space. If I'm out here, I got a lot more space around the nucleus instead of here. So think about it like little shells. So each level encompasses more space and therefore is capable of containing more electrons. Each level consists of subshells or sublevels. Okay, so they're going to have this level, and then exactly where in this level is that electron going to be. So this level is kind of like a big picture area, but then in that level I'm going to have a specific area, is what this is saying. And then each sublevel consists of orbitals. So I have levels, sublevels, and orbitals. And orbitals is the exact area that I can stay in. Okay, so you can kind of think about this as like you want to say where you're allowed to roam around and be. So you're saying like, okay, well, you have to stay in the United States. You can stay in the country of, in the state of Louisiana, but maybe you're only allowed to like hang out in your city. So we're being more specific about exactly where that electron is going to be located and kind of his boundaries. So when we talk about orbitals, the orbital is the wave function of an electron in an atom. So we're going to talk about what these orbitals look like. There's going to be pictures. But when you think about a picture, it's not that it's like this solid object and that the electron is going to hit the edges of this, and that's why it can't get out. What I want you to think about is if an electron is allowed to move in an area based on energy, repulsion, and all that, that if I map it out, so think about almost if I were to be like the electron was like a plane and I had like that smoke that comes out of it and I'm flying around in my area. That smoke is going to end up kind of making a trail. And then the trails overlap and all that, and then if it stays, I can almost see like a 3D looking picture of the area in which the electron can be around. So mathematically, we can actually calculate this and define the wave function. And so when we draw out the wave function using our math, we get what the orbital looks like. And so the orbital is just a region where we can find that electron at. Each orbital has a certain orientation about the nucleus. So we need to be thinking 3D. So we're not thinking like, oh, just up and down. We have to think about this way, and this way. So X, Y, Z axis. We have to think about all the axes. Each electron may be alone in its orbital, or it may be paired. This is really important. I want you to put like a big star or a circle or whatever. around this one point. Because this is going to be really important when we move into talking about, well, how many electrons are there, how many electrons total, etc. Every single orbital can have no more than 2 electrons in the orbital. That's it, 2. It can have 1. The electron could be just chilling in the orbital by itself, but the electron could also be paired. But you cannot have more than 2. Every orbital can only have 2 electrons. This is going to be really important when we start talking about the total number of electrons for each of these different types of overall orbitals and the sublevels. Okay? So 2 electrons total. So we need to be able to say where the electron is. So if I were to ask you, where you live, if I'm trying to figure out where you're at, how would you tell me where you were at? You would tell me your address. So if I want to know where an electron is, I need the electron's address. And that address is called an electron configuration. So I have to actually figure out what that address is. But before we start getting the whole electron configuration, and think about the whole address, there's parts to the address, right? You have all these different parts that make up your entire address. So let's first talk about one of the first parts of our address, our electron configuration. So the electron arrangement in the atom is similar to when we want to think about how many people are living in an apartment building or where they're located. So if I'm trying to tell you where I live, my position could be described a couple of different ways. I could tell you which floor I live on. I could tell you what type of apartment I live on. So what type of apartment I live in. Like, is it a studio apartment? Is it an efficiency? Is it a luxury? Is it in a penthouse? So this doesn't really tell you much about where I'm located, but the type of environment I'm in. I can tell you which room of the apartment. So now you know where I'm located even more specifically. And then I can tell you if I'm alone or if I'm paired. So this doesn't tell you where I'm at, but it tells you, again, describes kind of my circumstances. So these give me locations, these give me kind of circumstances. So we need pieces of information that kind of help me understand where I'm located, where am I at, and what type of living environment I'm in. So this is the same as if I'm talking about the electron. Where is the electron located? And what type of environment is it? What type of orbital am I located in? Am I by myself in that orbital, or am I with somebody else in that orbital, another electron? Okay? And so we need pieces of information. This is kind of like 4 pieces of information, and we're going to get 4 pieces of information that matches. So there's 4 different quantum numbers that relate to these 4 types of pieces of information. So my 4 quantum numbers is my N, my L, my ML, and my MS. They actually match kind of each one of these concepts. All right, on the next lecture, we're going to start getting into these 4 quantum numbers. I'm going to tell you what they stand for, what they represent in relation to this and the electron, and then we'll start defining how we figure them out.